Hi everyone, welcome back to the channel, and today we're going to solve Leetcode daily challenge problem number 76, minimum window substring. So we'll first check out the problem statement, then we'll look into the approach which you're going to use, and towards the end we will see the code as well. So starting with the problem statement, it is given that given two strings s and t of lengths m and n respectively, return the minimum window substring of s such that every character in t including duplicate is included in the window. If there is no such substring, return the empty string. Okay, the test case will be generated such that answer is unique. So basically you have to find out if t is a substring of s or not. If yes, then you'll have to find the substring with minimum length. Okay, which will cover your t. Okay, which basically covers all the characters from t, including the duplicates. So if a is occurring two times in t, then it should be there in s as well. Okay, so uh, they have given a few examples. For example, in this one, the t has abc and banc. Like this substring is the smallest one which can be used. So that's why they have output given the output banc here. And similarly, like we have two more examples. So let's check out the approach which we can use to solve this problem. And I am this approach, like, so when I was solving this problem, I think it's my second or third time solving this problem, and the first time I checked this one, it was from Neatcode. So it's a really beautiful channel on YouTube which gives really awesome explanation of videos, so you can definitely check that out as well. This is inspired, or this is a reference of that video only. So let's check out the approach. So now what we will do, we will basically uh, we will basically iterate s. Okay, and we will be iterating all the element only once. So there is a brute force approach in which what you can do, you can check for each substring starting with each index, and you can check if that is satisfying the requirements or not. If not, then you can move on to check for the others, right? But in this approach, we will traverse, or we will iterate through each element only one. So what we will do, okay, I'll start with this index. Okay, we are starting with 0 index. We will check. Okay, so before that, these are two variables which we are using. Satisfied basically means all the characters which has which has occurred equal number of times in the current window is of t. For example, if a is occurring 1, then we can say, okay, I have satisfied one of the characters or one of the requirements. So I'll treat it as three requirements. Okay, so I'll say, okay, one requirement satisfied. If b is also there, then I'll say, okay, now I have satisfied two requirements. So if my satisfied will be equal to my required number, then I can say, okay, now this is a possible substring, and we can consider it for the answer. Okay, but we will have to check for a smaller one as well. So what we will do for that, we will take we will go through each character. For example, we'll start with this, with a. Okay, I'll write 1 here. Okay, because this is what we have at the moment. B and C is 0. I have only satisfied 1. Okay, required is 3. Okay, so we cannot do that. Now I'll increase the size of my window. Now I have AD. D is of no use. Then again I will. Okay, so I'll just improve it a bit. This is the starting of my window. I have reached B now. Okay, now I'll say, okay, I have seen 1B. My satisfied value will be 2 now. Okay, but it is still not equal to my required number of uh, conditions, let's say. Okay, next is E. It doesn't matter. Okay, now I have C. Okay, now if you see, we have satisfied all the conditions or all the requirements, because my this value and this value is now equal. So what I'll do, I will store the start, end, and length of the window which satisfied this. So which will be 0 comma 0 1 2 3 4 5, 0 comma 5, and length is 6. Okay, so we have got one possible result. Okay, but now what I want to do, I want to check if I can get a smaller value or not. Okay, so okay, sorry, my bad. So currently I have B, C and A as well, but now I will move my window starting point to D. Okay, so now A will become 0. Now we don't have required number of satisfied requirements. Okay, so this is not valid. We will add another one. Okay, we will see if it is possible or not. Then we will continue with this starting point, with D as the starting point. Okay, and we will perform exact same step for all other characters. We'll have A, D, 0, B, E, C. Okay, so on and so forth. When you will reach, okay, when you will reach B, you'll say that this condition also satisfies the requirements, all the requirements. Okay, and interestingly, the length of this substring is smaller than what we have seen before. So now we will update this. This will be cancelled. Starting point will be 9, 12, and length will be 4. And we have done this because our length of the substring was smaller and it was satisfying all the requirements. Okay, so this is what we will be doing in the code as well. Let's check out the code for the same. So this is the code, and what I'm doing over here is, first, this is a base condition. If my t is empty or length of t is greater than length of s, then of course, like, we cannot find any answer from the given example or given test case. So then in that case I will return empty string, sorry. Okay, now this is count t, in which we will be storing the frequency count of t, and window as the it will be used for sliding window. Okay, now here what I'm doing, I'm just simply getting the frequency count of string t and storing that in count t. After that we have two variables, have and need. Have is basically the satisfied variable which we saw in the explanation. Need is the required ones. Okay, so now need is what, basically the number of characters in count t. Okay, or number of keys in count t, I should say. So this is what it is, and have is 0 at the moment because we have not seen anything yet. Next is, as I said, we will be storing starting index, end index of the window, and the resultant length. So this is what we are doing. In res, we will be storing the start, end of the sliding window, and length of course gives you the length of the shortest substring seen as of now. Okay, this L is assigned to 0 because as we saw in the explanation, we are starting with the 0th index. Okay, and with R we are basically traversing all the next pointers. So what we are doing over here we are checking if we have seen the element at current right index. So we started with A, for example, in the explanation, then C will have A, and in window of C, like window is basically the frequency counter for string S. Okay, I will add in the frequency of the current character. Okay, if the character is count t, basically if the character is in string t and the number of occurrence of that character in both the dictionaries or both the hash maps is equal, then we are adding one in the satisfied list. Okay, so we have satisfied one of the requirements. Okay, now what we are doing with this, we are basically greedily checking if we can satisfy or if we can get a smaller substring from that particular index or not. Okay, so this is the way to do that. So once we'll process everything, like as we saw that we were greedily checking if we can get more more substring which can satisfy all the requirements. So this is the part where we are doing L minus R plus 1. This basically gives you the length of the correct window. Okay, if it is smaller than rest length, then we are updating the result. Okay, otherwise what we are doing, we are we, as you see, like, once we have the result from A, we neglected that and we moved our left pointer, right? So this is what we are doing. So L pointer reflects to the left pointer, and we will remove 1 from the frequency count of character which is at point L, or index L. Okay, and if it is in string T, and like after removing 1 from the counter or from the current window, basically the hash map which is storing frequency from string S, if it ends up being smaller than what we require, then we are subtracting half, 1 from the have or satisfied list. Okay, and we are incrementing L plus 1 after that, and at the end, like, when we'll process all the possible substring which satisfy all the requirements, then we are returning this. So the check here is if my resultant length is not equal to float infinity, because that's what we initialized it with. So if it is not equals to float infinity, then I want to return the string starting at index L, ending at R. Okay, R plus 1 is because this is not inclusive. If it is infinity, resultant length is infinity, then I want to return empty because the solution is not possible. So let's check out the test cases. So test cases got clearly submitted for further evaluation. And as you can see, the solution got accepted, and we have performed fairly well, 82.94 percentile on runtime and 76.65 on the memory side. So yeah, thanks guys for watching out the video. Stay tuned for the upcoming ones. Don't forget to like the video and subscribe to the channel. Thank you.